21 of us. I guess if they've got comments during the call, they just raise them in the chat.
Yes, any comments, put them in the chat, and then we'll handle those at the end of the presentation.
Okie dokie. Okay, and hopefully everyone can hear us on the call. I'm going to be trying to ignore the microphone after this. Right. So this is the presentation. Hopefully we'll last about 45 minutes. We'll have some questions at the end. Quick agenda. We'll have some introductions, quick overview of the project, delivery, the elements of the project, so decarbonisation, capacity enhancements, some of the signalling stuff, and then some PWI. So we'll try and focus on some of the track elements in the decarbonisation, and then summary and learning points. This is going to be a whistle-stop tour, really. We haven't gone to touch many of the subjects in too much detail, but we can go into that in the questions. It finished around March time, so Alec and I might have forgotten some of the proper details. So forgive us, and also we've had a busy day so far. So hopefully the people in the room know who I am, but I'm Will Hastie. We'll get this person in. Hiya. Sorry. Will Hastie, associate in the Manchester Rail team. My background is electrification. My role on the project was contractors engineer manager, CEM, for the design organisation.
I'm Alec Paton from McDonald. I was the design manager. How we split the project, I was the western side, but I also went up into his CEM boots. I am a civil engineer with a background in railway stations, but I since transitioned a few years ago into the track team in Mods. So, okay.
Perfect. And the outcomes of this, hopefully you'll learn a little bit more. Maybe some of you contribute to the project, you can see where your work went, understand some of the innovations that we've done, and spoiler alert, we've been nominated for an award and won one award. A couple of learning points on how it was developed, and another spoiler, the project was paused at the end of our involvement and is currently undergoing a sponsor review. Then a bit of a summary of our collective efforts. So just a quick project overview. The background of this is way back in 2022, 2023, they developed the strategic outline business case for the upgrade of the CLC route, so between Manchester and Liverpool via Warrington Central. NRDD started to do some work across the various work streams that we're going to talk about. It then came into the decision point that maybe it's better to one of the framework suppliers do this work on behalf of Network Rail. So we entered some negotiations, and it came out that ourselves at McDonald took off the work from NRDD, not for the sake of delivery, but almost to take what they've got, build upon it, and use the elements that they've produced to date. One thing that they had done is produced an initial cost plan, but you can see that in bold, £775 million for the various elements of the scope. It was unpalatable, really, didn't push that cost-benefit ratio in the right direction. So one of our goals was to decrease that and increase the ratio. So we picked this scheme up in the winter of 23, negotiated, started project award in February 2024, and we effectively delivered for a year until the sponsor review in March 25. So everything you're about to see is about 13 months worth of work. A couple of things about the contract. It was a lead design organisation, so ourselves and McDonald were separate contracts. It wasn't a joint venture that you might see on the likes of East West Rail or NPR. We just had an overarching responsibility that WSP was a lead design organisation under 0209. McDonald had their obligations to feed into our work streams, but separate contracts. The premise was to do a desktop-only ES3, so we negate the costs and the program delays for that, and use everything we had in hand to deliver, hopefully, as much as we could do within the realms of the time that we had available. And we didn't want to throw any of that NRDD work away. It was useful. We wanted to build upon it, validate it, and use it where possible. So the scope of the project, hopefully people can read these off, and I won't read them too much, but they fell into some main themes. Decarbonisation, and decarbonisation was full electrification of the route, so between Trafford Park West Junction, which is just a few miles west of our office here in Manchester, all the way through to Hunts Cross, where you join the Ditton lines at Liverpool South Parkway. To do that, you need traction power interventions to feed the overhead lines with 5 new locations for either feeding or track sectioning. That introduces some issues at the western side at Hunts Cross, which Alec will go into. Then in a separate branch, capacity enhancements, so platform extensions, they did that to have longer trains, therefore more people can get on the train. So 14 platforms at what we declared were simple stations, plus 3 complex ones. Again, Alec can have that one. They were quite difficult. And then the CLC route, once you leave Manchester, Urmston area, you're into an absolute block section. So we were looking at how we can improve the signalling headway. So remove the block section, infill the signals, and hopefully get a headway through the route. We had some work about Trafford Park that got de-scoped quite early on. We've got some issues there about how the freight terminal works at Trafford Park. And ultimately, in a variation, because of the signal works, we'll get into it, we've then developed an options report based on how we could best deliver the signalling works. So what that looked like, again, this is from my mobilisation slides, 3 different branches of the kind of scope, all linked intrinsically, but different in their aspirations. So decarbonisation, so that's electrification, route clearance, immunisation of all the assets on the route. Also, that the scope for Trafford Park was in there at the start. Traction feeding, then you're at the second branch, capacity enhancement, so that's via platform extensions, complex and simple stations, capacity intervention. So we're looking initially at deconflicting the junction at Hunts Cross, Trafford Park, and then removing the absolute block section. And then into that also will be any route modernisation, work bank, interfacing projects. We'll take all that in. All of that feeds this cost business, business case. Alec, I'll let you go.
As the highlighting.
Who did that?
Right, so when we picked up this project, we decided to pretty much split it down the middle, which is at Warrington. So anything in the western half would generally fall within Mark McDonald, and then everything in the eastern half would generally fall within WSP. So we did that for, well, I guess one reason is we could have 2 teams working in parallel together to do the work quicker and hopefully learn from each other and the benefits that you can get from having different consultancies working together. There were a few differences, so I guess signalling, EMP, well, I guess you had the rail system sort of side that covered the whole route, and then I generally had geotech and some of the environmental sides for the whole route as well. Whereas the split was for civils, over bridges, traction power to power the electrification, the OCS teams themselves, and track as well for all of the bridge lowers that would be needed. So yeah, so the route goes from, so I should say, from Liverpool Lime, well, the passengers go from Liverpool Lime Street to down to Liverpool South Parkway, through Warrington, and then to Manchester Oxford Road, and then onwards. But I guess the core scope of our works are Edge Hill to Liverpool South Parkway were already electrified, so it was just capacity upgrades there. Then from Allerton Junction, which is next to Liverpool South Parkway, through all the way to Trafford Park area, where the existing electrification is again. That was all new platforms, stations, not stations, but platforms, OCS, etc. And then somewhere around over here in Trafford Park, it was back to the normal railway. So we didn't touch all of that, but generally we did touch most of it.
Mm-hmm.
It's about 28 route miles in total. The next slide shows.
Oops.
And we also had the dashed bit down there to feed the electrification. It was proposed to use something called the WIF, which is the Warrington Weaver Independent Feeder Cable. That starts at Weaver Junction down here, where there's an auto transformer feeder station site, and we would run a cable up the West Coast Main Line to eventually join the CLC line in Warrington. And this is how we split some of it up. So the diagram shows the western section and the eastern sections, and then some of the various disciplines that were involved in the project. Yeah, we were in a lead design organisation. I guess contractually there was no obligation we didn't have to work well together, but it was in our own initiative that we should do this well. If one of us didn't perform it, it wouldn't look great on either of us. So, but like both teams did really well, and we worked really well with the PEs and Network Rail. We had frequent meetings weekly, which really helped keep everybody on the same page, keep momentum building throughout the project, and they worked really well. I think we did pretty well on the DRN comment side. We were fairly well aligned throughout, even the different consultancies. With a bit of, I guess, gentle persuasion, we were very well aligned with each other as well. So yeah, we had 10 IDC IDRs, which is quite, I guess, not too many for a big project like this. I think that was fairly well condensed. Because there were, as I think at the next slide is, there's a hell of a lot of deliverables for this, 60 odd overbridges, yeah, lots of electrification.
And I'll just leave on. Yeah, as I said, no contractual relationship, but it's all about how relationships work. Everybody on the project, hopefully some of the people on the call, would all work well. That was MOTS to P, the vice versa, NRDD, Network Rail. We're all trying to deliver a project. The open communication helped a lot of where projects stall in terms of assurance, stakeholder engagement, interfaces. Just having it out definitely worked. So we had a project charter, MOTS, that helped. What we had, we've got a slide on it, option selection strategy drew consistency and continuity between decision making. That helped Network Rail. Where we wouldn't, where we showed our innovation is the application. And again, we're not innovating directly, we're just applying these new standards that hopefully one of the takeaways you get as these are now available to use at your own will. The suite of 27715, 6 and 7, we've got some slides on those. And push towards an MVP solution. That then led to, as you see at the bottom, at the end of our works, we reevaluated that cost estimate and it came down to 443 million. So still a lot of money, not to ruin it, but that's a 43% reduction on where they were at the start of the case. So at the start of our involvement. And that's not to rubbish the work that had been previously done. The work that had been previously done didn't apply some of these new standards. And also there's cost reductions as you move through the design stage in terms of the risk profile and cost of work done. So it was all very useful, but it shows you where the innovation would lie is if you can clear any of the interventions and not have to pay for them, then the cost estimate comes down. If you then got the benefits to prove that all works, then you're onto a good place. And what we did at the end, we had an overarching report, put all this out, signposted every deliverable we had, and generally gave a narrative of where the project's at. Hopefully that helps the sponsor review. So onto that option selection strategy, I thought this was one of my key principles, is that we're going to make quite a lot of decisions across the project from those different branches of the tree. Route clearance for electrification, placing of switching locations and TSCs, track changes, signalling changes, platform extensions. We want to have a consistent approach to those. So I sat down at the start and developed this strategy, very simple, as you can see by my diagram and my drawing skills. 10 criteria, a weighting mechanism, a scoring mechanism, tried and tested a few times and then rolled out. And it actually wasn't iterated later on. The first issue managed to cover what we needed to do. What that did is it gave us a tool to assess each intervention across these criteria consistently. It took into account things like capital costs, but also measured costs on a relative scale. As you see in the bottom right-hand side, interventions were scored relative to each other. The arithmetic brought out the highest option being the highest option being the best, rather than a kind of what colour is the most green kind of scenario. So generally worked every time. You've got to trust the process. It always took us to what the logical, pragmatic engineering solution was. And, it then gave us an ability to compare different interventions from different bits of the tree, compare your platform extension to your OCS intervention and the likes, which sometimes if you haven't done that, then you can't have different options and permutations relative to each other. So a good success for the project. Deliverable wise, there was a lot, as Alec said. The complex stations, Alec can present those. Each bridge, 61 bridges, had its own WOF, as it's called, works option form, that had content from civil structures and OCS in there, within a one-stop shop to get assurance for each bridge. 2 OLE AIOs split down the middle at Warrington. Traction power AIOs, again, incorporating those 5 different interventions. I won't go into the rest, but a signalling preliminary approval, quite a comprehensive, I thought, and good geotechnical desktop study. That's the top right-hand image with a long section and a plan of the geotechnical constraints. A very well-written planning and consent strategy to see how much of this work can be done within boundary and within their own permitted development rights, and overarching report. And then a suite of supporting reports and deliverables.
There is also the NRDD, who are still working alongside on some of their deliverables as well. So 14 simple extensions, EMC strategies, traction power, the higher traction power deliverables. So this is just what we did. There's still a whole host of other deliverables still out there as well.
And as you can see by the quality, I mean, we've got some of the designs in the room, so I won't go into too much detail, but the detail for our OLE layouts, we've got long section drawings, we had bridge assessments, all at ES3, all using desktop information, hopefully de-risks where we need to get to for the next stage for the end product and teases out constraints, issues. You know, it's not an AFC drawing, but it's a whole lot better than any ES3 you would get in a very walks life. So very proud of the two OLE AIOs that definitely appraise the route for its electrification needs. So here we go then. I'm going to go now into three sections: decarbonisation, capacity enhancements for Alec, and then I'll come back to the signalling one. So as you can see, that's the problem. I think I can't remember where it is, Flixton Station. A lot of the contract bridges are very low naturally. The track has been lifted over time. There's your EMR train and you're only just getting through the structure itself. Unfortunately, we've got another 20 or so bridges in the same format across the route. So this was where we get to as I was kind of building on for decarbonisation. The design itself took on 85 SDK. We also had the 6 kilometres of existing electrification from about where Cornbrook tram stop is, all the way down to where Man United's ground at Trafford Park is. Existing trolley wire for electric vehicles into the what needs to be upgraded for mainline running of EMU vehicles beyond and onto the at Trafford Park. It turns into the Manchester Aldridge and Junction lines. As I just said, very detailed desktop study. 77 layouts in total, so quite a lot of work went into them, and the assurance from the NR teams. And we know each structure drawing and each clearance assessment we built up, we went through it. We did an option selection, so we did an option endorsement workshop, we did an option selection workshop. That then fixed the permutation of what we're going to produce for the OLE AIO. And then that went into the works option form, which confirmed and got the PRE sign in to each of these options. And after people on this call and in here left, I took those option forms and we got the majority of them signed up the first time. It shows that, you know, the work we did and the week that we took that on the journey helped in terms of any pushback from a PRE team. So where we got to with the actual standards innovations, and I'll let you read them in your own time rather than me, but we applied them, and we were probably one of the first projects to really be given the full extent of application. Things like TRU and other projects and have a standards baseline, which precedes what we've got here. So we were allowed to be let loose with everything that they entailed, and we did generally go to as far as we could go. I think it's in the right for a designer at ES3 to push what we've got in our design capability all the way to the limit, and then have a structured conversation about how we bring it back to what's appropriate for maintenance and anything like those. So go through them separately, and I've got a slide for each with some very crude annotations. There we go. So this is the CLC route. It's not really, this is Great Western Main Line. One of the things that came out of 27715, which is all about the design parameters for the electrification itself, is structure spacing. So it increases the maximum span from 65 meters up to 95 meters, which is quite a large increase. And if you put that across the 85 route kilometers of the route, you can say, I haven't done the maths, but Network Rail did some math, and they say that estimated 5% of your previous structures will be saved because you've got to account for over bridges, junctions, and the likes. I think on our route, because it's so straight, we would generally have more of a saving, but unfortunately, we didn't get through the previous design to tell us what the saving is. Let's just say 20%. That sounds good. That gives us greater flexibility. Again, this is very crude, but the previous ones are in green, and I showed in red where you could be getting to. Gives you great flexibility to extend your spans to bypass things like underbridges and constrained point and things like that. Generally speaking, where we had tangent track and the wind speeds allowed us, we could go and get to the maximum spans. I don't know how many spans we actually placed at the theoretical maximum, but any span above where we were before at 65 is a benefit. So a really good innovation. And one thing that happened in the cost was that the previous unit rate for electrification used the Midland Main Line or whatever, a unit rate using the old standards. When we reevaluated it, we used a reduced rate to account for the fact that we'll be placing less structures in the same length of track, and that's less foundations, less construction time. So some of that cost reduction came from the reduction in number of structures from this increase. So great advance there. 27716 is all about clearances quite a lot of detail in there. Again, please read in your own time. And again, very crude drawing from myself here. That's a proposed OLE wire to this bridge. What we're trying to show here is we can minimise with the application of surge arresters, voltage control clearances, and then also more recent enhancers in minimum contact wire height and the likes. You could really push the overhead line close to the structure as possible, taking in the additional mitigations required that come out of the standard. But also the standard gives you a risk assessment built onto this, and also all the infrastructure required to do this is all kind of baked into it. So what was before a novel enhancement is now a very standardized approach, and lots of projects are going this way as well. For me, if you can clear a bridge like the one we've got here, I can't remember if we cleared it or not, it unlocks everything because they've got utilities, they've got major problems with them. And just at the end there, standardized approach for track fixity and track vertical allowance. The standard details quite clearly what we should be giving from a track perspective in terms of future allowances. Well, sorry, allowances for the track vertical and horizontal fixity, but then also future allowance in the TVA for how much maintenance can be provided. Now, if you're going to have these tight tolerances, you're going to have to take some sort of concession on how we maintain it. And we had various discussions where the route wanted to maintain the track and the bridge very much like it wasn't electrified, which they can do, but then that requires an intervention to do so. So we went around that loop a few times and generally came out on the right side, showing the client team where, if they wanted those additional tolerances, where they would have to pay the price of a bridge intervention and the likes. So it's all about people understanding the new parameters and the likes. And I
say we were asked to consider whether discontinuous electrification or permanently earth zones would be a possibility for this, but generally, because of the low clearances and the fact that VCC allows you to pretty much have the wire height the same height as a permanently earth zone, there wasn't really any benefit to having discontinuous electrification. And I assume projects in the future would probably avoid PEZ permanently earth zones where there's no electricity in the wire, so the drain power's down. The only benefit is if you were to go the discontinuous route, you would have to get rid of the wire under the bridge completely and just have the pantograph bolt down on the train. If you did want to keep the clearances, if the clearances were too tight and the bridge was impossible to rebuild or track lower impossible to lower.
And it opened up the whole conversation on what rolling stock are going to use this. It's a known diversionary route between Manchester and Liverpool. And then if you were going to introduce things such as permanent earth sections or discontinuous electrification, you then constrain the rolling stock that can use it. And maybe that's an operational, maybe that's acceptable or maybe that's not. And we went through some of that, and the general consensus was that it wasn't acceptable, and therefore the cost plan and the design was reflective of a full electrification of the route. But we were cognizant of some of the benefits that discontinuous electrification brings. Right, still on 27716. That also, this is Liverpool South Parkway, so not the best example, but it was the best photo of a station I had. It gives you additional benefits in writing a risk assessment and providing a structured approach to public protected clearances of platforms. So what we've got there, again, very crudely drawn, is your former OLE height, 3.5 in green, and then where we can now reduce the wire height through a platform going down to the red. And there's a set hierarchy of how you'd approach that, and a difference in the tool for assessment, which has been something in the industry that's been kind of rumbling along, and lots of things have gone on there since the 1210 and now into the 27716 availability. And we did have some sessions with Richard Staten, Authority for Overhead Line, to run through our application just to make sure we're interpreting the way that his standard is written, to make sure we get it correct, and also to feedback any issues or nuance that we found in this application. So that image on the right is a cross section to show you some of the protective clearances using the new anthropological method, including the taut string line, which allows things like account for train body as a protective element. Again, won't go into too much detail. All of this aligns with 501221, and all of it gives you the benefit of being able to reduce the contact wire in the platform without introducing the CSM risk. Well, sorry, you still introduce that CSM risk, but you've got a more standardized approach to how you deal with it. and a pre-written risk assessment, which you can then call upon and do a bespoke one where required. So there's not an issue here at Liverpool South Parkway, it's already electrified, but some of our stations, quite a lot of them, have got an overbridge right at the end of the platform, and it's like 4.3 metres off it. So if you can then, in other projects, you'd have to redeck the bridge, not for the sake of the clearances at the bridge, but for the sake of the clearances of the platform. If you can actually now keep the bridge because the clearances of the platform are acceptable to the new standard, another great saving. Right, and then the final one of the three is 27717. This one outlines a methodology for assessment of clearances to electrical clearances from a parapet perspective. So from an overbridge down onto the electrical equipment on the railway. And again, we apply, rather than a standardized approach of what was formerly a 1.8 meter parapet, and I've just shown in the right hand image what we used to have to do. Just a flat 1.8, and there was derogations possible, but generally speaking, we then did that. That then causes you some civil issues sometimes. We've got a historic bridge with wind loading the parapet, then you need to underpin the deck and put a concrete drop in, those kind of things. What we do is assess it using the model at the bottom left from 501221, which again assesses a taut string line to see what's reasonably practical, accounting for the red zone, which effective clearance 600 millimeters. So Network Rail put that all together in a standard template, which takes into account these values, which you can input into it, as well as you can do it in a CAD perspective as well. It then takes into some other details, such as the locality, the risk of trespass, and other more personal style details to give you a risk profile for each bridge, and then it gives you an associated cost what you think would be worthwhile doing for the parapet increase. And generally speaking, it comes out of it's disproportionate to do any intervention if you can pass the taut string line. So in the previous cost estimate, we had quite a large number of bridges, if not all of them, required modifications. We applied this new methodology, the new spreadsheet, and some of the outcomes of that, and we could get rid of that cost because we could prove that all of the interventions passed the taut string line. There were some where you had to infill mesh parapets. You still need that solid 1 meter at the bottom, but a lot of them, like this one in the bottom right, passed as it was rather than. So again, lots of cost savings in terms of materials, but also construction consents for third-party bridges and the rest of it. So another great saving, another good application. And then also embracing track lowers. We had two instances where we actually had, you can see on the right, a load of they've muted themselves, right? A load of bridges in a row, which then also failed electrification clearances, and would require either, what would this be? This is Glazebrook Station on the right, and going west, you were effectively required to rebuild 5 overbridges, including quite a large overbridge at the station. There's a picture of the station, bottom left. The track actually sat quite high due to maintenance, so the offsets weren't that good. So what we proposed, instead of the kind of more wholesale large intervention of the overbridges, was to look at a longer track lower, holistically taking out each of these bridges to then effectively try and hit all the birds with one stone. Lower through for electrification clearance at each of the structures, put the track back where it should be potentially, and fix the offsets of the platform, and also allow for then a platform extension at that new track design level. So we managed to prove via a collective option selection for these 5 bridges here at Glazebrook and another suite of them at Padgate that this is the right option to do, taking into account the wider, rather than taking into a discrete nature, we took into account the wider holistic view of this bit of the railway and what's the best outcome for it. And it generally scored the highest, even though you do have other things like the actual level of intervention for a kilometre of track lower and the like. So I think those 2 interventions test that rule where we didn't have this because we didn't have any track bed investigation, but we generally thought that the ballast depths were high, they've been lifted over time and filled, and therefore we did propose track lowering without touching the formation, but actually when it came out, none of those options came out the best, even though they are quite a pragmatic solution. And we had other issues that changed the grade.
We did have a bit of a hierarchy on how the bridge replacements, track lowers went, and that was generally, if it was a footbridge, you would replace that as a footbridge if it was cheaper or the cheapest option. Then it would go down to a track lower if it was a road bridge, because all of the utilities that are in the bridge are quite expensive to divert and then put back in afterwards. And then generally the most expensive option was to replace the bridge, like for like, but slightly higher up to get the clearance. Yeah. Multiple locations where we had track lowers.
Mm-hmm. Yeah, and embracing those, because other projects, and it's anecdotal, isn't it? But track lowers are shied away from for various reasons, and they are. If you want to try and affect as little as you can outside of the rail boundary, they're the winning solution. But they do come with their own complexities and drainage and track profile and the rest of it. But they're not a do not mention or do not touch. They're something to be investigated and proven. Where that came out with, again, these numbers, please, the NLDD numbers were with the tools that they had at the time. We had a different suite of tools, but as you can see, coming top to bottom, LDO, parapet compliance, 27717 application, dropped them all out basically across the board. We had some with non-solid lower 1 meter sections, so mesh infills and the like. So we still had to do some parapet compliance. Track lowers, there was none previously proposed. I mean, they didn't have much time for their design. We then brought in quite a few of them, which were possible to do that. Reconstruction of footbridges, we had those at some of the stations where we had steel lattices that couldn't necessarily be modified for the solid parapets because of the loading capacity.
We also had some that were normal bridges that were just used as pedestrian bridges anyway. We thought, why would you replace it like you would reconstruct as a footbridge instead?
Yeah. Reconstructions, and here's where your cost savings are. The reduction there is huge. I can't remember the numbers at the top of my head. I think it was 27 or so down to 3 or so. And those 3 are going to be the showstoppers, the big ones. They're going to cost you a lot of money, but at least you then don't have the fee for the big ones. Those, as I remember, the ones for the reconstruction were some of the eastern platform ones. No works required, dropped out. Increased, and then we had one where we managed to get it agreed that it was a demolition because it didn't really have a use. It was stocked up anyway, but we have to go through the process of proving that. And then finally, away from the actual OCS side of things, traction power was a different story. We had 5 locations. The feeding arrangement was slightly contrived, and still the current thinking, I believe, that from Weaver Junction, so that's where your Liverpool branch of the Ditton lines breaks off on the West Coast Main Line. There's a feeder station there, water transformer feeder station fed from Frodsham. You then get 2 interconnectors, extension cords, and run those 16 kilometres up to a new proposed feeder station at Warrington Central, close on the western side of Warrington. And then you would feed out CLC route in Magenta there with various TSCs at Widnes, Earlham, midpoints at Trafford here, and Allerton on the far side, which was going to be provided by others. So quite a lot of work done there on the independent feeders, because running 16 kilometres of new cable diverse across each side of the West Coast Main Line, across things like the Ship Canal and through a few tunnels was quite complex. But we got an outline completed for that.
I think this was the most complex bit on the entire project. Was the fact that at between Hunts Cross, West Junction and Hunts Cross Station Hunts Cross Station, there's the existing Mersey rail services, and they use a third rail DC 750 volt contactor that our proposals were going to cross over, and AC and DC don't mix very well at all. I think you can, but there are issues. So historically, some of the area around Hunts Cross West Junction was electrified, but it's been sort of thinking that one day the route might be fully electrified. They never did it, and all of the existing electrification has just been slowly stripped back to Allerton Junction and the depot, mainly because of this cathodic corrosion. So a lot of the bases at the OLE masts were corroding there and having section loss to a lot weaker. So they had to cut it all back. But yeah, so we're proposing to then put an AC railway, overhead railway back over, and then that has a load of issues well, we would still face the issues. There'd be hazardous voltages between the two systems. There could be EMC interference, various things being induced. There's stray current from the DC. It generally leaks into the earth as well. They really don't mix, and throw on top of that the signalling system. Got to find one that suits both. So we started off. Network Rail came up with sort of 4 options. I think we added a 5th one onto that around. So we had 5 options that we were considering for how will you rectify this area. Option number 1 was you just get rid of, so the diagram on the bottom shows the train pattern, and you can see the yellow crosses over the blue lines, and then there's also a bit around platform 2 where Merseyrail don't tend to use it, but they can in an emergency. This platform there that we have to sort of keep. First thought was, why don't we just strip out all of the third rail here, and then Merseyrail already have some battery trains. They're sort of proven technology. It's only going an extra mile and a half further on from Liverpool South Parkway. So that would be for the infrastructure side. That was the best option. That's the one that we, I guess, chose without stakeholder consultation. Then we have 3 options around some technology called isolation transformers, which essentially you place these isolation transformers at the start, or at a point near the start, and a point near the end of the third rail section, and it creates a bit of an airlock. So any trains moving through that section won't then connect to the other sections and won't bridge the gap, so to speak, to the rest of the network. We also have something called DC contactors, which are used in dance. But all of it's actually used at isolation transformers and DC contactors are all used down in London. So Thameslink uses DC contactors to switch between overhead and third rail when they go through the centre of London, and isolation transformers are used on other parts of the London Underground network rail interfaces. So we considered those. There were 3 types. Generally, they are more expensive from an infrastructure side. They're also quite, I guess, complex to get your head around how they exactly work. And then the 5th option was actually, why don't we look at completely rearranging Hunts Cross Station? So you end up with 2 Merseyrail trains, or the 2 Merseyrail lines just go to platform 1, and then platforms 2 and 3 are used by the other services, and then you completely separate the system. That, I guess, there are a lot of benefits to that, but there's one quite big negative in that it's really expensive to do that around Hunts Cross. But I guess after stakeholder consultation, the cost of new battery trains is prohibitively expensive. They need, I can't remember how many, but it was, I think, 18 or so new trains at about, and they're at least 5 million a piece. So massive cost. Possibly could retrofit them, but we're not too sure. It's not been done. So essentially, at the end of the stakeholder workshop, we chose option number 2, which was to put isolation transformers around there.
The isolation transformers option put all the cost into the network rail pot. It's the most infrastructure heavy, cost heavy as well, apart from the relook, mess around with all the platforms. But it solved the problem in a passive way. So again, a bit of stakeholder consultation put that on to us. Right, just won the awards. If you want, I can go and get it. It's in the kitchen here in Manchester. We were nominated for one of the RIA, Railway Industry Association awards. We were actually highly commended, and we actually received the award for that. And Sir Andrew Haynes, not in his speech at the award ceremony himself, emphasised that slashing the cost of electrification is a key point of what the railway needs to be doing in the future. And I think that is why we then ended up with a highly commended award in the innovation criteria. And the innovation, as I said at the start, wasn't us being too outside the box. We were only applying the rules that we've got in the new suite of network rail standards. If you take that away, is to go and use them to the full extent. And I've copied the same header twice, but we've actually been nominated again, put an application in for the Spotlight Rail Awards in March next year for the Net Zero Pioneers. CLC route is a mixed traffic intercity route between Liverpool and Manchester. There should be a case for decarbonisation on it, and everything we can do for decarbonisation feeds into the net zero goal. So we'll wait and see. Hopefully we'll be double award winners, notwithstanding the fact this project was paused. So we're going to be in the most awarded awards programme. I think we'll see. So roughly, that's what that looks like in a schematic format. You've got the electrification in the central section on the right-hand side of the trolley wire upgrade. It's not to scale, it's rough itself. Then we've got the interventions where we've got red for reconstruction, blue for the track lowers. As you can see, those groups of blue require the longer track lowers, and then the tractor power locations underneath that. Capacity enhancements.
Yeah, stations and signalling improvements. So the stations, there are, well, not every station along the route needed a platform extension, and a lot of them, which we're calling simple stations, where the station you could just extend. It was quite obvious which way the platform was likely to be extended. You could just go down and assess. There might be a signal or a load cabinet that you might need to move, but generally these were all undertaken by Network Rail, NRBD, and they were quite obvious and easy to do. It's the problem where we get the more difficult ones, complex stations, but a lot of the platforms are fairly short. There are extensions up to almost 60 meters to get to 148 meters, which happens to be the length roughly of the class 331, the northern sort of electric trains, which is where it's envisaged might run on this route. So they're the 14 simple stations, which include Mossley and West Allington on the Liverpool spur, the West Coast Main Line. Then we have complex stations, which were Liverpool South Parkway, Hunts Cross, and Warrington Central. These are complex because there's no obvious way to extend the platform. Each station had, if you were to extend it one way, you would end up into a bridge that you would need to replace, and that's massively disruptive and prohibitively expensive as well. Or if you tend to go the other way, then there would be signal that switched across ABS-C that you'd have to push away. Again, also quite expensive. So it would, and certainly at Liverpool South Parkway and Warrington Central, where it's a lot more congested, so there's a lot of junctions and bridges. It was really, it was going to be really expensive. Our methodology when we came up with the ideas of what to explore and what not to explore, for example, at Liverpool South Parkway, I think when we were endorsing options to explore, we quite quickly got rid of the one that was to relocate Allerton Junction further south, because you just end up running yourself and all the track and S&C work through into Allerton Depot. I don't think you'd ever end the track works that you'd have to do to that. But I think obviously that would be massively disruptive and really expensive. We also had another problem at those particular stations and some of the others that you might see that the required length for some of the platforms is 154 meters, and that's because Transpennine Express on their class 185s, which they would still continue, which they propose to still continue to use on this project after it had been done. They use something called a CASDO, which is a coach automatic selective door opening. So the train, when it arrives at the station, it knows which side to open the doors and also how many doors to open. And that's located in the front or the rear of the train. And because it's the system doesn't have a lot of torque, if the platform is too short, the system won't recognise that it has met this belief that goes on the forefoot, and it won't open all of the doors. They've had this problem. We tried to argue the case, but they've learned their lessons. They know that to make it work reliably, you need a longer platform. So that's another slight added complexity to that. I would say that Hunts Cross doesn't have those calling it. Doesn't have Transpennine Express calling at it, but that's because of signal standback issues. It has a slightly longer platform. But yeah, Liverpool South Parkway, Warrington Central, through stakeholder consultation. It wasn't on the cards at the start, but through stakeholder consultation, none of the talks really minded that they were to continue using selective door opening. So that essentially was the logical solution, and probably one of the biggest cost savings. So the project was getting rid of those two stations. Hunts Cross, however, that wasn't too bad. We managed to work an option that would work for that. So we managed to move a crossover further east towards Manchester and rejig the signalling around there. We also combined that with a track lower that was happening through one of the bridges at the end of the platform anyway. So we managed to make an efficiency there that if you're going to do this work, you'll do it when you do the track lower as well. So that one was extended. Oops. Yeah, and then that's a schematic of all the stations. So Liverpool, Wedge Hill, they weren't really in our scope. They stay the same. Any red is where platform extensions are going to be undertaken. And then the blue one is Oxford Road, which is being remodelled. That wasn't part of our scope.
No.
It's something we were aware of. And then we've got the signalling side, which is the absolute block removal. So between Warrington Central and Glazebrook East signal box, there is something called block signalling, which is, this is on the top right, there's a picture of the instrument that they use. So just there's at the bottom, there's a little tapper that rings a bell in the other signal box, and that's how they communicate to each other. And then there's some dials that say whether the line is clear or not, or normal. I think there's a guy called Bill Graham or Grampus who does lessons on block signalling if you're interested, from Network Rail. It's quite an interesting way of signalling, I would say, but it has some problems in that it's manual. I think in the timetabling you generally have to add a minute or so. It doesn't work very well if trains are delayed and can sort of impact, because it's only 2 aspect signalling. So it makes sense to modernize and get rid of this small bit. And yeah, so that was get rid of that, put new track circuit block signalling in, 3 aspect, extend that 3 aspect towards Hunts Cross, where there was also some 2 aspect signalling. Then you also increase the train bursts as well between the sections, so the signals are spaced according to the speed. That makes it a lot more efficient. If things go wrong in the timetable, late train, suddenly you've got a lot more flexibility that they should be able to make up the time in the timetable, which is something that currently affects this line. Yeah.
And as you can see, yeah, we had to infill where the block section is. There's no signals in between that. You're running between the sections of the block section. So you would take that away, replace that with track circuit block, and then infill with automatic signals through that bit. As Alec said, you get a headway, constant aspect sequence, and more bursts for trains. The route is between Castleville Junction and Allerton Junction. So you want to, if you can try not to be firing trains into there, and you could have a few more berths within the CLC route as it is.
This is a schematic showing these are the areas that the signal boxes control. The bottom half, this one's Cross, Warrington Central, Glazebrook and East Junction signal box. That's where the 2 aspect signalling was. That's where the absolute block was. And then, yeah, if you get rid of it, normalize it, so it's all basically 3 aspect track circuit block at this point, except for the bits controlled by Manchester Rock at either end, which are 4 aspect.
In the middle image is Warrington Central signal box, which unfortunately sits right in the way of the platform extension east. So that did come into considerations for that. And if you're going to go in and do a lot of that work, here's a picture inside Warrington Central signal box. As you can see, a lot of white levers. I mean, they're disused, and they formerly was a bigger box itself. And the routes, so they've had some timetable issues, and they used to run the consistent stopping train from Liverpool to Manchester via Warrington, Manchester Oxford Road via Warrington. But now they run it in 2 halves. You run a Liverpool Warrington turnback service and the Manchester Oxford Road Warrington turnback service. So a lot of this was to reinstate that through service. But because of the way the connections are either ends, got issues with Castleville Corridor and the Ditton lines. So because we were going to go and do a lot of work for decarbonisation, electrification, and also the infill of the absolute block section, we commissioned a study to have a look at what's the best way to do that. And this is only at high level principles and not too much walking about, is the fact that because of the infrastructure out there, it's electromechanical, so it's getting on to over 100 years old easily. It's been tampered with along the lines, but it's not a relay-based interlocking. You still have the lever frame and then relays based off that. A lot of that isn't consistent with electrification, unionisation. You don't want to have any wrong side failures and the like. So you'd have to immunise regardless. But also now we're going to infill and change all the signal positions through the route, the new aspect sequence, move all the track IRJs throughout that bit of it. So is it best to only immunise and not do the capacity side of things and electrify? Maybe you do that, but you just extend the existing signal boxes, or maybe you go and recontrol the whole thing, take it out to the Manchester Operations Centre, bite the bullet, and go for a computer-based interlocking. What that gives you is the future-looking aspect for recontrol back to the MROC, and also any considerations for ETCS and future developments. So we conducted a study. It was ourselves, WSP, with a signalling design work, Volker Rail, and then Network Rail had some expert signalling cost input, as well as the PREs for the area came and gave us some information about the maintenance costs. Because again, there's a lot of extra kit going on there. There's an extension of electromechanical, more modern, more maintainable, and more manageable kit when you're going for a CBI. So we went through this exercise. We took the option selection strategy that I talked about earlier, modified it slightly, just to account for some of the nuance that the signalling side has. It's ETCS readiness, recontrol readiness. Does the route have an aspiration to recontrol that? Maybe it is for a few construction periods time. So we went through that. I won't go through all the details, but what we did manage to prove, both qualitatively, as in kind of intrinsically, that's the right thing to do is recontrol, but also quantitatively with the numbers that we allowed for in terms of cost, indirect whole life cost in terms of maintenance savings, and the rest of it from anecdotal savings that we've got, proved that we could effectively, the best option would be to, if you've got the commitment to it now, over a 20-year period, it pays back that money that you would have spent on the cheaper option now because of things like maintenance costs. And then, then you think about what you'd actually have to do in 20 years about your recontrol and all those issues that you kick down the road. We took that to a stakeholder meeting and we got it endorsed. And just the middle bullet points, whole life cost of the recontrol comparable, notwithstanding, there was some large COPEX costs. Obviously, it costs more at the moment to go and do a full CBI recontrol of that route. A new front-end processor, MROC and the likes. We also went one step further, which was, well, if you are going to put the CBI in, what would you do? What would need to be done to do ETCS in that on the route? And what we found was that the Northwest isn't necessarily as prepared as we thought it was, and we went through some of these motions. And I won't go into it because I realised we're quite short on time. But effectively, what we realised was the train fitment programs were actually happening more quickly than we thought. So I go to the top right there, this full house question mark. We went through the report. We produced some architectures that we thought would work. You could actually, and we proved it by this, you have all the right things, the full house, to actually go straight from where you are at the moment to an ETCS railway signals away, if you had the appetite to do it. So that's all trains are equipped for ETCS. That would have been by 2032. Training complete. That's a big one because everybody doesn't want to be the first person to implement it because the training requirements, the network change process, and then from a constructability and assurance, we had methodologies of how you would actually implement it, and how you commission both sides of the system. You could run it as it is today, have a system underlay, effectively commissioned, and run that and do all your online testing and commission. So it was a really good report and a really good workshop. And it was something that then added weight to the requirement to go for the recontrol if you wanted to. Now that cost for the re-signalling and the effective recontrol was then quantified, went into that total business case. So that 443 number also includes for the signalling. So it's not a complete like for like. We've actually got a lower cost but more scope in some cases because, as Alex said, some of the bridges for the stations dropped out. So that is me rushing at the end here. There we go. That's Allen Junction. Here's the whole thing. Roughly, I'm not a systems engineer, but I've tried to show it. Top to bottom, the signalling ones, we went through that and Alec kindly presented. Electrification in the middle, platform extensions at the bottom, and then a rough outline of what the services are. The CLC route has that issue where it's got stopping commuter services, whereas intercity services that run quite long distances across the north of England from Liverpool to Cleethorpes and Liverpool to Norwich, as well as, unfortunately, at the eastern end, we've got Trafford Park, and then that all connects to the Castlefield corridor. So that's all quite positive, but unfortunately, as I said, it's paused. Here's the status as we got to. So March, we were given instruction just to kind of wrap it up. It wasn't going to progress where we are. We didn't effectively get preliminary approval for our signalling design, but we left it in a good place. The sponsor-led review, because of that work we did in the business case, reduced it so much that then we're going to do a review and see what's best for what's the best outcome for the CLC route. And that was all driven by, or could be contributing factors to, some of its big brothers, Chat Moss, so the next route, Liverpool to Manchester North, CLC, already electrified. As I said, we've got the Castlefield corridor as the entrance on the eastern side. We've got projects to remodel Oxford Road and provide bi-directional signalling from Oxford Road down the initial part of the CLC route. There is still in development. NPR Liverpool to West Yorkshire. that's starting to mobilise. They've got a route that's effectively going to run a parallel route between Liverpool using the Ditton lines to Manchester. So that we need to understand that interface. And the freight liners Trafford Park Tunnel is effectively going to move out the city centre and negate those freight trains in the Castle corridor. So that's where it currently stands. Hopefully, when I was speaking to somebody the other day, they think that the business case has tangible elements to it, and I'll see some part of CLC progressed. Maybe not that full diagram, that's the best case. I'd like to see electrification go forward, especially with some of the signaling elements. Actually, I'd like to see it all go forward. But yeah, you've got to be realistic. The whole thing is about doing the appropriate amount of infrastructure modification to provide the most quantified benefit. So the learning points, I'll just quickly run through them. Relationships work really well. As I said, no contractual relationship, but everybody got along like one big happy family. Obviously, we had some instances where, we had conversations, but transparency helped, and there wasn't necessarily no big fallouts. Those working relationships were not just us, Alec, Watson, WSP, it was also Network Rail, and also from Network Rail to different parties. So from themselves, from the project out to the route teams, open communication, dialogue works really well. There's no guarded conversations in that respect. And similarly with TOX and DFT, when we got the opportunity to present to them, they were fully engaged, and we went through drivability, SORAT, and the rest of those kind of things. And we also presented to the combined authorities in Liverpool because they've got different aspirations for things like Homeless Cross. Progressive assurance worked well. We didn't necessarily have any major faux pas in terms of assurance of documentation. Closeout of documentation assurance by DRMs was done via open communication calls rather than horrendous spreadsheet-based DLN reviews. And then challenging to apply the standards worked really well, and that's where the awards have came in. Option selection strategy was simple but effective and appropriate for what we needed to do. And ultimately, I then sat down and went through each line of the cost plan painstakingly, which I think was useful because you need that engineering input, and all of those things then led to that reduction in the direct costs and also some of the other values that make up the cost plan. And I missed one, the desktop study, again, worked really well. The program implications and the cost of surveys for the benefit they give if you can corroborate existing information is something to be thought about when you're starting any project. Ultimately, you need survey information for detailed design and the rest of it, but it's what's appropriate for what you're trying to achieve. And this was all about changing the business case. I've got, well, I'm 1 minute overdue, actually.
There's one question when it comes to both this. There's one question in the chat. Appreciate you saying you need to have an increased OE structure space that's 9,500 services. Perhaps on the crosswing cost likely on the contact.
Someone's going to be in there. There's obviously a methodology that you go through to actually allocate a span of that length. You take into account some of the oscillation of the lines. You take into account things like the wind speed. And that also takes into account things like the local orography and the height of ground and the position you're in. So yes, it does ultimately, but I think what they've found out in the application of the new standards is the previous conservatisms for that. Actually, you were conservative, you could actually go for the span. That was then dynamically tested at places I forgot, I think it was on the bit of the mainline, and sort of improved the effective. You've got to think about that because it's now in the network rail standard, so already being tested on the application.
Any more in the chat?
I don't think so. Oh, we've got a hand up.
Yeah.
You can unmute and go for it.
Hi, good afternoon. It's Panelli again. In terms of the low clearance bridges that you have, was there any consideration given for rigid contact wire system, or like we know with the Bracknell Willis aluminium contacts, which effectively take out your full catenary system?
Yeah, there was. I think I would say that nothing was off the table for the discussions. I think you can't quite see it on this one, but the girder is in quite a lot of the bridges. There were jack arches between the girders, and we went through a whole process of how you could, take that support up, if you can't see it, up in between the two girders, and therefore only have the bridge arm down quite close. I don't think we ever went anywhere as far as allocating a rigid catenary system, contact system, but it could be something to develop moving forward, depending on what the solution needs to be. think that's okay. Was there any more questions in the live chat?
In the room?
None in the room. I realise we're up, you may as well.
Yeah, okay. Yeah, thanks to all and Alec for a very fascinating, detailed presentation. And just say I worked on the project and it did work really seamlessly. And I think I can relay what you were saying in terms of how well the two teams really worked as one team, and that the option selection process of being able to compare what are quite different interventions. So, and as you say, the testament is the fact that all the projects are now, starting to use these standards, and really hope we get some future momentum on the projects. Many thanks.
Great, thanks. And if anyone on the call, still on the call, just reach out to myself or Alec for questions, or maybe go by the PWI secretary. And anyone here, you can come and catch me in the office, or go and catch Alex in the office. Cool.
Yeah, and just before we finish, just another recap. The next presentation is on the 4th of December, which is the joint presentation with Chester, North Wales section on drainage, and that's also here at WSP First Street. And as you should know, as members, there's the vote for the name change for the Railway Engineering Institution, and votes are open until midday, 16th of December. If you can cast your votes, and when we go ahead, if 75% vote in favour, and of course the seminar next March, which preparations are moving very well now. So on the 18th of March, developments in S&C design, manufacture, installation and maintenance. So hopefully see you all there. Right, thanks so much.
Thanks.
Thank you.